All right, but that's where we've got to stop so we can start. I think that's, I'm just missing, wait, double check. Vanessa, no Vanessa on the list. Okay, then we'll start there. Good afternoon, everybody. All right, good news, bad news. Good news, I got the speaker connected at least, so I'm just going straight there via Bluetooth. So at least I have sound. I can hear you on, not on the monitor, I can hear you on Zoom. And plus I get the music now, which puts me in a better mood, and that always produces better results. But I still have no projector screen, so unfortunately, the two of you here in person, you will still need to join the Zoom call so that you can see what's going on. Okay? Speaking of seeing what's going on, can people actually see my iPad screen? Yes, okay, good. Last class, I got through like the whole lecture, and it wasn't until the very end, they're like, I have no idea what you're talking about. I can't see anything. Like, you let me go on this whole time. Guys, don't let that happen. If there's ever a problem, if you can't see something, you can't hear it, speak up, let me know. All right? Okay, where were we? We're doing geometry stuff. We're finding angles of stuff. Dealing with angle relationships. Today we're going to bring in the parallel lines. It's going to be great. Oh, go ahead and mute. Thank you. So, answers from yesterday are here on screen. Go ahead and take out your work and check it there. There's Vanessa. Good. Most of these were fairly straightforward. Simple match one to the other, bit of subtraction on the supplementary parts. Probably 5 might have been actually the trickiest, just from trying to see this overlapping of the 90-degree angles there. But they are marked. You have the digital edition, so you can zoom in, make use of that. Right, the next set, 7 through 10, you're determining the truthiness of each statement. Is it always true? That is to say, you cannot find any counterexample. There is no disagreement. Is it sometimes true? Like, I can think of one example, but I can also think of an example that it doesn't work in. So if you can think of one of each, then it's a sometimes true. And if you can't think of any cases where it is applicable, then it's never true. Totally false statement. Okay. And then 11 through 15 here, just fill in the blank, most of these based on the definitions there. Not much more to say unless anyone have any questions from yesterday's work. No? All right, then let's move on to today with the parallel lines. And I want to bring everything together and talk about how we can make a shortcut, basically. Because those conjectures are nice. They're really good for justifying your answer. Okay? If you need to explain why you know something. Oh, I know that this one has to be congruent to that one because they are vertical angles or because they are alternate interior angles. That's good for one at a time. But when you're in a hurry, or you're faced with questions such as these at the top, where you just need to find the answer, or on the SAT, right? You don't really explain your work on the SAT. You get the correct answer as quickly and easily as possible. Okay? Every shortcut is valuable, especially when the SAT likes to throw this kind of stuff at you where they make it more complicated. They're going to throw more things in there all at once. you need the fast, easy solution. So here it is. If you can remember this about parallel lines, you'll be set for finding any angles. I've color-coded them for you. Because as it turns out, we can justify each pairing independently, but in the end, they all come together, and you only have two different measurements. There's only ever two numbers in a set of parallel lines crossed by a transversal. Now, if they add any additional line segments or angled portions in here, then you've got more to work with. But from this basic setup, all of the acute angles are going to be congruent to each other, and all of the obtuse angles are congruent to each other. And this lets us really generalize, because now we can say that any combination of one of each, any acute angle plus any obtuse angle, since they're all the same anyways, is going to give us 180 degrees. Any combination is supplementary. All right? And that makes questions on here really quick. For example, look at question number 1. They already give us this angle here, 54 degrees. And we can classify that angle, both by how it appears. It is smaller than a right angle, and the number given is definitely less than 90, so we know it's an acute angle. So we can go through here and just visually find all the acute angles. There's one, there's the other one. I've got all 4. And all 4 of them are going to be the exact same measure. So we know right away A is 54 degrees, B is 54 degrees, C is 54 degrees. Boom, done. That's it. There's no additional thinking or work required from there. If you also wanted to know, say, the supplementary, we could do that real quick. 180 minus the 54. Let's say 80 minus 50 would be 30, but I took away more, so reduce 30 by 4 more, 26, carry the 100. That's 126, that's 126, that's 126. So we can just fill these in. And that's how I would approach all of these. Even if you don't need to, I would just fill in anything you can, especially when you get to something like number 7. There's a lot going on. You only need to find a few of these angles, but I bet you it's going to be easier sometimes to find some of these that are unmarked here in the middle. Maybe that guy. That one might be important. I don't know. It might be easier for you to just go ahead and figure out anything you can figure out. Fill in everything you can fill in. And then focus on, okay, which ones do I actually need to report as my answer? Okay? When you get to things like 8 and 9, oh, the SAT loves doing this. They cannot leave a simple geometry question alone. They have to throw in some additional algebra on top of it just to make things harder. That's really the case. They're just trying to waste your time. But it is somewhat of a realistic scenario. Maybe not quite to this extent, but it is totally feasible that you would know how two measurements relate to each other. I know that this measurement is 30 more than that measurement, rather than knowing right away what the actual measurements are. That can happen. So it's a reasonable practice. Okay. Any questions on finding angles in parallel lines? No? Then we are actually going to turn away from this document, and I've got a quiz for you to test your mettle and your speed. And the great thing about a quiz is it provides live and instantaneous feedback. So when you are finished with the quiz, what you can do is review it and use that information to further improve your skill before tackling today's exercises. So please go to joinmyquiz.com. Enter the join code 213,779. We've got one in. There's two. All right, one more minute to join in. All right, and let's begin. How are we doing? 62%. Okay, not bad. Not bad start. Keep bumping it up there. Right. Oh my goodness, 6 done already. Very nice. 7. Excellent. So when you are finished, go ahead and switch back to the worksheet for today. Work on those exercises. We've still got, lots of time. We've got 24 more minutes left to work. Have at it. Switch back to that.